Okay, welcome in. In this video, we're going to discuss matrices, important object in R. I like to think of matrices as a two-dimensional vector, so check out our vector video if you haven't already. And let's start by just straight away defining a matrix. So I'm going to say X, and I'm assigning matrix to it. You can see that matrix is this nice function that's in the base package of R, so you don't have to download anything for it. It's so crucial that it kind of comes with R. And we're going to do something simple and just, you can see a really nice part about R is that the arguments of the sort of function pop up. So it says data, n row, n call, by row, et cetera, et cetera. I'm going to start simply and I'm going to say my data equals 0. N row, that just stands for the number of rows. We're going to say that equals 10 and n call equals 10, which is just the number of columns. So there's a couple of other arguments, but they're not super necessary. In this case, we're just going to say matrix of 0, 10 rows, 10 columns. I'm going to run this data. You can see it's now in my environment and in the console. And if I print out X, voila, you're going to see I have this object. It spills into 2 lines, unfortunately, but there are 10 rows, there are 10 columns, and all of the values are 0. So that's a matrix. It's, a 10 by 10 table. In this case, I just put 0 in as the data, so it's going to fill kind of in that way. Now, let's say I actually want to fill this with some data and do kind of something cool with it. So let's say I'm going to do the, I'm going to fill it with the numbers 1 to 100. Remember, this colon means we're going from 1 to 100, counting by 1. That kind of makes sense because I have a 10 by 10 matrix. So there's going to be, 10 times 10 is 100. There's going to be 100 values. I run this and I see my matrix. So I have all my numbers 1 to 100. They count all the way up to 100. And this is not what my brain thinks when I am typing in 1 to 100. My brain expects the one to count this way. So for it to be 1, 2, 3, 4, and kind of for each row to increase like that. The way to specify that is with the by row argument, and you just set that equal to true. If you run this now, you're going to see what to me looks like a more intuitive matrix: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, etc. But you do have to specify that by row equals true. One quick aside before we kind of keep going here: what's going to happen if I do X? If I do the data from 1 to 50 for X? So take a second to think. I'm going to run it, and then we're going to see what it looks like. What do we think this matrix is going to look like? So hopefully you remembered R's recycling rule. Basically, we only have 50 numbers for 100 spots. So we use all our numbers, as much as we can. We get to the 5th row and the 10th column. I'm going to move this over so I can see more of it. Get to the 5th row and the 10th column, we have the number 50. And then in the 6th row in the 1st column, we go back to number 1 and we recycle from there. So that's kind of like how R will recycle. If I put in something like 27, I'm going to get a warning because 27 does not factor into 100. So we're going to have like the recycling is going to end on a weird note. It will still work, but the last number of the matrix is not going to be 27. It's going to be 19, and we're going to have 8 left over. So that's just a quick note on recycling. Let's go back to our original matrix, 1 to 100. Very nice, very clean. And let's just do some simple matrix calculations. So one nice thing we can take is the transpose, which if you've taken linear algebra kind of means we're just going to flip X on its side. We do that with this nice T of X. Again, T is like, this is a super useful function, so we don't actually have to write out transpose. We just, R has T. And if we run this, we see we kind of just flip the matrix. We rotate the matrix by 90 degrees, which incidentally is the same as doing by row equals false. But sometimes, you don't have the option to do that. You just have to take the transpose. Other nice functions that are built into R, one is call sums. This is basically just saying call sums, or sorry, I just repeated the word. This is saying take the sums of the columns. And this is, again, a base function, so it's built into R. If we run this for X, it's going to give us the sums of all the different columns. So, here's column 1, column 2, etc. And at this point, it's probably useful. I'm going to print out X again. It's probably useful to think about this notation. We can always think about the location of a matrix in terms of these square brackets. So you can see in this like thing, it's saying square bracket, empty space, comma, 4 square bracket. So here, the first like number after the square bracket before the comma tells us the row, and the second number tells us the column. So in this case, we're not putting a number down for the row, which means all rows, and the fourth column. So we're looking at this fourth column here. If I typed x79, that's going to give me the value in the seventh row and the ninth column. And I run that and I see 69, which is here's the seventh row, highlighting the seventh row, and then the ninth column, which is our number 69. And we can do other things. We can do like x1 to 4, 8 to 10. This is giving us the rows 1 to 4 in this matrix and columns 8 to 10. It doesn't even have to be in order. We can do rows 1 and 7 and column 8, and that will give us, I'm going to do column 8 and 9 so we get a matrix. That will give us the first and seventh row and the eighth and ninth column of the matrix. So that's kind of a way to like subset and pick out values of our matrix. And this like row column notation is important to know. So anyways, I was talking about col sums. There's also col means, which gives us the mean of each column. So again, we look at each column of the matrix, we take the mean, and there's also row sums and row means, which will do the same thing, but by rows instead of columns. So the sum of the first row, the sum of the second row, et cetera, et cetera. So very useful built-in functions. Matrices have really nice properties similar to vectors, where we can just do operations very efficiently and quickly on them. If I wanted to do x plus 7, right? I'm gonna go in my console and do that. Let's say I just want to do x plus 7. Automatically, that's going to add 7 to all the values in x, and it's very, very fast. Very easy to do. If I want to do x divided by 10, divides everything by 10. This last column is nice and even whole numbers, but simple to do. And the last kind of nice property of these matrices is they're easy to bind together. So one useful function, yeah, I'll do it in here, is called rbind. Again, it's a base function. R stands for row, bind stands for bind together. So let's say I want to bind together x and x. We take x here and we bind one on top of the other. So here's the top is x and the bottom is x, and we're binding the rows, so we're stacking them on top of each other. So we now have a 20 by 10 matrix for R bind XX. And if we do C bind XX, we're going to combine matrices on the side. So we put one matrix next to the other one. You can't really see it here because you can see it, but it's just like stuff is the window isn't big enough, but we're putting the matrices side by side. We can run this nice function dim, which is a very useful function. Stands for dimensions on this matrix. This tells us that the matrix has 10 rows and 20 columns. And our last kind of question for today, if we want to find the dimensions of the transpose of the C bind XX, what are we going to get? So hopefully you said 2010, because the transpose of C bind is just flipping the matrix by 90 degrees, which gives us this, and that's the same as R bind, row bind. We have 20 rows and 10 columns. So hopefully that makes sense. Matrices can get pretty complicated, but they're very useful in R, and we'll see you next time when we talk about a different R object.